First of all, I'd like to thank Professor Cho Jimmy for inviting me to this forum. And I'm very honored to make this presentation on behalf of our integrated team in 2 of our 8 national laboratories within the NALabs. And the integrated team includes my colleagues from National Space Organization, NSPO, which builds the thermoset satellites, and also the National Center for High Performance Computing, the NCHC, which operates the HPC and the cloud computing facility in Taiwan. Next slide, please. And in recent years, Open Data Cube is being promoted by the CEOS, which is the Committee on Earth Observation Satellites, which provides a potential solution to facilitate various applications of multi-temporal and multi-sensor remote sensing data. And this solution has the advantages of easy management, high efficiency, and it shortens the time to decision making. Next. And Taiwan initiated the Taiwan Data Cube, and we started development in 2017 after a GEO meeting in New Mexico City. And this initiative in Taiwan is a domestic alliance of National Taiwan University and some research institution in Taiwan. And we had general support from Australia, the CSIRO. And after building a prototype, we engaged in Global Forest Observation Initiative, which is short for the GFOI, with the first application in forest management. And then we injected Taiwan's thermoset satellite imagery. And just last year, in 2020, we completed the trial operation. And that was followed by recent launch of the TWDC in the normal operation phase from January of this year. Thank you. Next page. And the NALabs has built a TWDC that contains the imagery from Taiwan and the United States and European satellites. And analysis-ready data of the thermoset is generated into this data cube, while the infrastructure is supported by Taiwan Computing Cloud, TWCC of NCHC. And the performance of this TWDC is thus enhanced by the capacity of the HPC Taiwan Near 2. And that has the speed of 9 petaflops. Next, please. And another feature for this TWDC is the multi-cube service framework. We have created the framework across various cubes to promote the effective networking from different satellite sources, and also further accelerate the cooperation, the operability, and experience sharing between the data providers and the users. Based on the Taiwan Data Cube's service system, Earth observation applications can be extended to across many disciplines. And the cubes can be either public or private, and also can be either free of charge or non-free. Next chart, please. And currently, TWDC is capable to conduct integrated cloud analysis, which means users are able to drive the TWDC on the TWCC cloud from local platform, which users are familiar with, to conduct required analysis, and then display the analysis results locally. In this specific case of NCDR, which is the National Center for Disaster Reduction Technologies, they select to use DataCube and selects the product type and sets up the parameters via QGIS. When the analysis is complete in cloud, the analysis results is automated to display at the local user end. Through this TWDC integrated cloud analysis, efficiency could be further enhanced. Next. And this TWDC has attracted nearly 20 teams to join in our trial operation phase. They are from the government, academia, research institutions, and some private companies. Applications covers detection in agriculture, water quality, marine environment monitoring, land use classification, forest wildfire, and etc. These applications are aligned to the universal values today, which is the UN SDGs, climate actions, Sendai framework for the DRR. Next chart. And these applications are aligned to these universal values. And it is also noticed that these practices are implemented in Taiwan and overseas too. It has free of charge, but users are obligated to provide their feedbacks as a means to improve the system. I will use two examples as a showcase. Next slide. Next, please. No, the previous one. The application in DRR, yes. For the disaster risk reduction, this example shows you a flood module that we have developed, which is developed to demonstrate the efficiency in emergency disaster response practice. In normal operation of spaceborne emergency service platforms such as Sentinel-Asia, the time between emergency observation request and the delivery of acquired images, along with an analyzed inundation map, is critical. In this example, floods occurred on August 26 in southern Taiwan in 2018. Because of extreme rainfall, the ARD of Sentinel-1 radar backscattering coefficient has been used to extract the flooding area. With the TWDC flood module, time for the EOR to results delivery can be considerably shortened. Next slide, please. This is the second example, which is an application for the paddy rice detection. And this chart shows the first application in this field. The joint research project in precision agriculture is being conducted with our partner in Thailand. Together, we are building a data cube in Thailand in agriculture and food security issues. And in this project, AI is being applied to monitor and analyze the distribution change of paddy rice in this region. And finally, I'd like to make a summary of my report. Next chart, please. The Taiwan Data Cube facilitates an efficient cloud computing platform in support for the multi-temporal analysis of satellite Earth observation images. And this platform will lower the technical barrier for users to exploit the power of data from the satellite, and hopefully from UAV too, with algorithms in various applications. And applications of TWDC can further provide substantial societal benefits to achieve the SDGs across the communities, including the government, research institutions, and academia, and also industries. Having said that, with advantages of this data cube, we would like to work with you to build international partnership. Thank you.
Okay, so thank you,